So yes, my name is Massimo Candela, and first of all, I'm extremely happy to be here because this is my first in-person meeting since 2020. So I'm really happy to see you all. So NTT, I'm a senior software engineer at NTT, and NTT is a big company that offers a lot of services, among which we are a tier 1 provider. And I work in the in our global IP network that, as the name suggests, is a large network, and to manage such a large network, we need a lot of automation and monitoring. Essentially, we need softwares to keep the network under control, and that's what I do together with some amazing colleagues. Essentially, my goal is to find occasions for improving our operations, to reduce the possibility for errors, and to ease overall the operations. And today I will present you what we did for RPKI. In a past meeting last year, during the RIPE meeting, I presented what software basically I implemented for the automation and monitoring of RPKI. During that presentation, as always on point, at the end of the presentation, Randy Bush asked, "Oh, but what about numbers? So what about numbers of errors that you were doing before, and how many you are doing today?" And today, the focus instead will not be so much on the software itself, but on those numbers. And I hope that sharing them with you may help you your operations and your RPKI deployment overall. NTT is doing route origin validation since March 2020. This is a screenshot of our official announcement on the website. And doing route origin validation is just one of the initial steps of RPKI, and the other one is, of course, to sign ROAs. Unfortunately, I see a lot of workshops and tutorials that they just stop there. So they focus on, okay, now you sign the ROA, yeah, RPKI done, that's all. The reality is that the RPKI is a new layer, a new dimension that you will have to keep in mind every time you do your daily operations. It's going to be always there. You have to keep an eye on it. It requires additional knowledge, of course, but it requires also additional procedures. And while for other technologies that they have, or technical solutions that they have been there for a longer time, we have a lot of best practices already known. For RPKI, as a community, we are still developing them. And this is essentially the topic. What can happen? In addition to sign your ROA, it is common, for example, if you take RIPE REAST data, or anyway route views or BGP data, you analyze that, you will find that during day-to-day, a lot of RPKI invalids get announced, and announced also by autonomous systems that they are doing RPKI. It is pretty common. So what I am talking here is that there are what I believe 2 common mistakes during day-to-day operation. So like you want to announce a new prefix, but you completely forget about RPKI. Sometimes you forget. Other times I get this feedback you know, it's not a problem because it's going to be unknown, and so everything is going to work as before RPKI even existed. But the question is, are you sure that it's going to be unknown? I mean, did you check? Do you have a procedure that says before to announce that check that is going to be at least unknown? Because if you have a less specific ROA with a different max length, you may do RPKI invalid. Or you may forget, or you may not forget about RPKI, but you forgot about timing. RPKI has some time that you have to take into account. So there is publication time when you sign a ROA. Some trust anchors, they take hours, up to even 24 hours to publish those. And in the meanwhile, you may not be covered by the new ROA that you created. And there is a natural propagation time because you created, and everybody else has to do another validation cycle and create a new VRP file with all the new RPKI, with all the new VRPs. So You may think also that's not really a big deal. It's invalid. At some point, it's going to be valid. Well, it depends what type of service and what type of customers you are dealing with. Because if you are doing operations for a large, for example, CDN, having for some hours RPKI invalids at the best gives you suboptimal routing. In the worst, gives you partial, unreachability. So it is something that you have to keep in mind. So what I did here is, I want just to give you the real numbers. I took one calendar year, 2021. I took all our logs. We have an installation of BGP Alerter, which is this software that we created that is open source and you can also use. And we have it for basically, I took all the logs, not only the logs, I also took the tickets that they get escalated to our NOC about these alerts. And when I say alerts, I'm talking, or errors, I'm talking here about RPKI invalid announcements. And so why I did that? Because I wanted to see the real root cause of each of them. So I manually inspected all of them, get all the data, and sorry for the 4 categories. I just discovered that there were 3 categories, not 4. 3 categories. One is the wrong max length. So basically, we do the error that I was telling you before, where basically we announce something and we say we forgot about updating the ROA. The other is announce a customer prefix, but they had no ROA for our autonomous system. 2914, so customer address space, our announcement. You may think also in this case, well, that's not your fault, it's the customer's fault. Yeah, but there is at least space for improving communication with the customer or a procedure. And the third is, there is we migrated prefixes from one S to another autonomous system, but we forgot about updating the ROA. So now these are the, so we have 71 cases in 2021 of RPKI invalids that we unfortunately announced. And you can see that basically the biggest majority, 57.6% are the max length issue, so the problem I was telling you before. And the second, we announced customer prefix is almost 17%. And the third case, the migration, is surprisingly 25.5. Actually, I was not expecting that. But to be fair, it was one single event where we had multiple prefixes involved. And the numbers here are per prefixes. So now, you may think, well, some of this, they get resolved because they may just propagation time, maybe transient, so not a big deal. But as I said, there are some that they do RPKI invalids for months. And if you are not monitoring, how do you define it's going to be transient? How do you know that? Also, another reason for monitoring is that even when you are not doing RPKI invalid, but some prefixes become unknown. There are some known software bugs in routers that have been documented, most of which fortunately patched, but they were pretty serious stuff. They were switching from when a prefix was becoming unknown, were transitioning from valid to unknown, passive by invalid. So for some time they were rejecting. And ROA may disappear because they expire, because a trust anchor may fail, and we will see some cases like this before. So being informed about these cases, imagine, like, I don't know, a RIPE NCC, a RIPE trust anchor that goes down, and you start rejecting all RIPE prefixes. It may be serious, so you want to be aware of what's going on around you. So how did we address the errors that we saw before? So the first thing is, as I said, we introduced a new automation platform. So this new automation platform is not the focus of today, but we also improved our monitoring. So we introduced some RPKI-specific monitoring and alerting, and this you can also benefit from this in the open source BGP Alerter software that I maintain in the public Git repo. We introduced strict procedures to follow and improve the communication with the customer. So all these points, they go hand in receiving end. I give you an example. Now, when we have to start announcing prefixes for the address space of a customer, our monitoring platform says, okay, but the customer has to add this ROA. We communicate with the customer adds the ROA. Only when we see that ROA and the platform gives us the green light, then we start doing the announcement. I want to show you the results that we got. This is a small window of 2021. We introduced the system in March, 26th of March. Basically, what happened is that we got a reduction of 86.84, so basically almost 87% of our occasional RPKI invalid. And with the new system for the rest of that year, 2021, we tested, stage, and monitor new ROAS for an amount of 565, just to give you an idea of the amount of new ROAS created with the system. So this is just, I repeat, it's not the focus, but I want just to give you an overview of the platform I developed. This is basically the dashboard where we are able to see all our prefixes and their current status, like they are valid, they are visible, they are monitored. And when you click on one of these prefixes, you can do various things, among which the part that we care today is the RPKI. So I divided this in two parts, the current RPKI status and the future RPKI status. The current RPKI status is what you can see with public RPKI validation. And the future RPKI status is what you want to achieve with adding or removing ROAS. So at the bottom, you can add and remove ROAS, and these are stage dummy ROAS, and now we will see what they are. So basically those ROAS, plus the real ROAS, they contribute to the future status. So I defined these 4 steps that we adopt internally. I call it the 4 stages of ROAS, and if you're telling me that the first stage is denial, that joke was already made. So the first stage is when the ROAS is staged. So basically, we create those fake ROAS internally. We merge those with the public ROAS in the repositories, and we use that to validate the future state that we want to reach. And when all of them, when everything is fine, then we commit all of them. It's an atomic procedure, or all or nothing. When they are committed, they are ready to be shipped to public repositories, so to become real ROAS. And at some point where they will become for real ROAS, then they will be marked as public. So we are in the 3rd step. That means that our RPKI in that moment is up to date, and possibly also our BGP and RPKI are in sync. And what we can do next, what happens next is that after 24 hours, we mark them as stable. Marking them as stable means that there was no issue for 24 hours. We will keep monitoring them forever. The only reason, because there is this 4th step, is just to give a closure to the procedure of, for example, creating ROAS, so the tickets can be closed. Software that you can use if you want to monitor your RPKI. So the first thing is BGP Alerter, which is available in this repository. For any information, you can also contact me, and it does real-time monitoring for BGP and RPKI. It is easy to use. You can do auto-configuration, no installation required, uses public repositories. Essentially, it's a binary that you run and works. It does a hijack detection, visibility loss, path monitoring, this for the BGP part, but there is also the one that we care for today, RPKI monitoring. Another important software that I have to thank is the OpenBSD RPKI client. So BGP Alerter out of the box connects to public VRPs. However, it is important that you instead want to feed your own VRP file for the output of your own RPKI validation, and you can use whatever RPKI validator you want. However, if you use RPKI client, basically there will be, they introduce, and when I say they, I am talking mostly about Job Snyder that helped me with this feature, which was also, by the way, one of the important members in our, because before it was an entity, our RPKI deployment. Basically, RPKI client exports information about a raw expiring, and you can have also that alerting already integrated out of the box with BGP Alerter. So, but so concretely, what you can get is you can receive for the RPKI part alerts if your autonomous system is announcing RPKI invalid, or your autonomous system is announcing prefixes that they are not covered by ROS. If you have a partial RPKI implementation, you can disable this, and so you don't get annoyed by these alerts. You can get information when ROS covering your prefixes, they disappear. And you may be surprised, this is pretty common. I repeat, it can be just your VRP that is malformed. It can be a human error that somebody deleted the raw of your colleagues, but it could also be trust anchor failures. We will see some of those later. Or raw involving any of your prefixes was edited in some way. We have a Slack channel where basically everybody that does any change, we see almost immediately, bam, notification what change was done that is visible in the RPKI. Also, trust anchor malfunction, as I said, and VRP corrupted, so specific alert for that, and expiration of ROS. Not only of your ROS, but also of all the other certificates that they are in the chain of validation. Now, this is a screenshot. In particular, you can look at the second one. This is the diff I was telling you about. So if you or your colleagues or anybody edits your raw, you will see the diff. That's already interesting to have this kind of feedback back in your operations. Now, if you are not convinced yet about the monitoring part, about monitoring RPKIs, and I want to show you here a list of cases of trust anchor malfunctions that they happen in the past 2 years, essentially. And if you have monitoring in place, these are cases that we discover and we inform the related party. So if you have monitoring in place, first of all, you will be aware of what's going on around you. And you will be aware that maybe you will not spend time debugging something that is not your problem. But maybe you can contact directly who is in charge for it and can fix it. So you also are doing not only a favor to you, but also to the entire community. These are basically bits of the public RPKI infrastructure temporarily failing. So in the 12th of August 2020, BGP Alerter reports many prefixes no longer covered by ROS, and some users, they start writing me and they say, look, maybe these are false positive. We were already investigating because we also had the same situation. They were disappearing from AREN. So at that time, we started investigating, in particular, Job Snyder, the RPKI client team and the AREN team, they do a call and they managed to fix it the same night. This is the public announcement that after they did, it was an error in how certificates were published. And I took that as an opportunity to introduce some new trust anchor monitoring features. So not only something related to your ROS, but also let's monitor the trust anchors. Let's provide specific alert for those. So the 6th of February 2021, we have TNIC ROS disappearing again, and BGP Alerter sends alerts, and after TNIC reports that it was a hardware failure on their side. The 18th of March 2021, we discovered that we missed RIPE ROS in one validation cycle. What that means is that we had all valid ROS, and maybe after 50 minutes, another validation cycle, some ROS were missing, another validation cycle, ROS were back. So since this happened already in the past, thanks also to my colleague Colin, he took some logs. We provide a report to the RIPE NCC, and they fix it. This is also an official communication from RIPE NCC. Basically, what happened is that there were, we find some manifests containing reference to certificates that were not there. And the issue was mostly that the directory, the public repository was updated. And if you were doing rsync in the meanwhile, you were maybe getting partial update and partial old stuff. So 17 June 2021, we discovered lacking disappearing over rsync. Our RDP was fine. This was a cute one because we WhatsApped our friends at LACNIC, and they fixed it in like not even 30 minutes. Possibly the world not even notice about this. 1st of February 2022, JPNIC partial trust anchor malfunction. So in this case, they were not disappearing ROS, but they were expiring soon. This is the log that we got from our ROS expiring. It was weird. Also, were not our ROS, but it was something in the chain. We report to JPNIC, they fix it, and they fix it, a nice part, they fix it 1 minute before the ROS were going to expire. So, well, maybe it was not going to happen anything because they were just becoming unknown, but as I told you, this unknown thing is not really super bulletproof, so glad that they fix it in time. And this was one of the examples of, like, basically by doing this, we provided another public service. So 16th of February 2022, RRDP RIPE.net becomes unreachable. And unfortunately, also the backup on rsync, because everybody was moving to rsync and we were getting too many connections. So we detect the issue, we contact RIPE-NCC. In that case, to be fair, RIPE-NCC was already aware. There was a DNS misconfiguration. They were already working on it, and they provide a fix already on fly. And this is the official report. So the list is over here, and my presentation as well. So I hope you got some interesting information, and if you have questions, this is the moment. Thank you very much.
So we actually have a few minutes for some questions. Anything on RPKI for Massimo? It's a very interesting presentation. Anything on trust anchors, RPKI?
Don't be shy.
We can give you a microphone.
Sorry?
Is anybody always...
The monitoring, you mean? Oh, yeah. Well, except for us, of course, that we are... Oh, I have to ask the room. OK, now I got it. Is anybody... Yeah, repeat the question. Is anybody of you using already BGP Alerter for monitoring of BGP or RPKI? I see 2 hands, 3 hands, 4. OK, good. So at the moment, actually, is well, since the question is there, at the moment, actually, is particularly used. Maybe not in this room, but it is particularly used, and there are around 400 installations worldwide, and among also important players and big CDNs, and it's something that we use in production ourselves. So if you easy to use, if you want to do it, then would improve and ease your daily operations. Any other question? Perfect.
OK, well, please join me in thanking Massimo again for a wonderful presentation.